All right, guys, this is our FRQ for week 13 notes. Let's go ahead and begin here. So, tells us functions f and g are differentiable. That means you can find their derivatives. Tells us that g is strictly increasing. I'm not too sure if that's going to be, yeah, I guess it'll be kind of helpful, but that just means the graph goes up and it never stops going up. It never has a time when it starts going down where it goes up. But I don't know. That probably won't be horribly important to us for what we're working on today, but we'll see. The table above gives the values of the functions and their first derivatives at selected values of x. The function h is given by this. That's going to come in handy. Here we go. Explain why there must be a value r for r being between 1 and 3. So there's some value of r between 1 and 3 such that h of r equals -5. Now, this is an IVT question. Okay, that's an IVT question. That we should recognize that from the work that we've been doing this week. So, how do we do the IVT? Well, the steps I told you in class was, you want to identify your A, your B, and your K. So my A is 1, my B is 3, and my K is -5. What do I mean by A, B, and K? Well, those are just the letters we used when we were learning about it. The next thing that we want to do is we want to find h of A, and we also want to find h of B. Now, in this case, my A is 1, and my B is 3, right? Now, you don't have to write these letters, and in fact, I wouldn't, on your FRQ, because anytime you write a new letter on your FRQ, you have to tell them what those things are. So I would just start by writing h of 1 and h of 3. I'm just writing it, though, to connect it to what we learned in class. So, h of 1 and h of 3. Well, h is equal to this. So h of 1 is equal to f of g of 1. Now, well, let's simplify that. G of 1, according to my table, is 2. Now I want to find f of 2. F of 2, according to my table, is 9. And 9 minus 6 is 3. So h of 1 is equal to 3. Let's do the same thing here for the next function. F of g of 3 minus 6. All right. G of 3 is 4. F of 4 is -1. And -1 minus 6 is -7. So, after we find h of 1 and h of 3, we next have to make sure, is it true that my k value is in between these two values? Yes, it is true. -7 and 3, 5 is in between those two values. So that checks out. Okay. Next, we want to make sure that this function is continuous. Now, I couldn't find an FRQ that would state that in the instructions, but for now, I want you guys to understand something we'll learn later, is that if a function is differentiable, then that means it has to be continuous. Now, we haven't learned that yet, but I'll just tell you that's the case. It is continuous. So I've got this function now. It's continuous. And we're going from -7 to 3. So therefore, yes, at some point we have to cross -5. So we're ready to go ahead and write our statement. So what we would say is, we would say since h is continuous and goes from -7 to 3 on the interval 1, 3, there must be some value, and the letter they're using here is r, some value r such that h of r is equal to -5. So it's an IVT problem. Okay, what kind of work would you need to show on this? Well, really just two things. You would need to show your work of how you got 3 and negative 7, and then you'd have to have your paragraph. The rest of it's really not needed to be written at all. Okay, so that would be part A. Let's move on to the next one. All right, for part D, they're telling me G inverse is the inverse function of G. Write an equation for the line that's tangent to the graph of y equals G inverse of x at x equals 2. So if I want to find a tangent line to the graph of G inverse, then I need an x value, I need a y value, and I'm going to need a slope. Okay, now the x value they give. So how do I find the y value? We find the y value by plugging the x value into the original function. So I want to know what's G inverse of 2. Well, we have to remember how to work with inverses. G inverse of 2 is equal to something. And that means that G of that something is equal to 2. So I want to know what x value gives me a G value of 2. So I'm going to find where G equals 2, and I'm going to find the x that goes with it, and the answer is 1. So my question mark is 1, and therefore the outcome is 1. Now I'm ready for my m. To find your m, you need to find the derivative of G inverse of x. Well, if you've already done the College Board review, this might be a little fresher in your mind because there's quite a few questions like this on the College Board review. But there's a formula for this, and that's 1 over G prime of G inverse. And once again, we're going to plug the 2 in. Now I already know what G inverse of 2 is. It's 1. So now I need to find G prime of 1. And according to my table, at 1, G prime is 5. So this is 1 over 5. So now I have enough information to write my tangent line. It's y equals slope times x minus the x value they gave me plus the y value we found. And there you have it. All right. On your practice for this week, I included a question that's not going to be talked about in this video. That's for two reasons. One is I feel like it's a little bit straightforward, but also because you guys need to also start kind of getting used to seeing things that are not being explained to you step by step every once in a while. You need to learn how to take the things you've learned and really start thinking on your own a little bit, because that's exactly what the AP test is going to be like. So giving you guys an extra problem to think about in your practice a little bit. But from there, I'm going to leave it to you guys, and I'll wish you a good day, and we'll see you in class. All right, guys, this last one I'm going to go over is not on the page in your blue book. So I'm just going to encourage you to go ahead and add this in on that page. I'm using the same table, but I'm adding this problem here. All right, so we're going to do find a limit here. Now, the first thing you do when you do a limit is you plug stuff in. You're going to do direct substitution. So I plug in the 3. Now we're going to evaluate it. So g of 3 is 4. So I've got 3 f of 4 plus 3 over f of 3 minus 10. Next, we're going to go ahead and find out what f of 4 is and what f of 3 is. So f of 4 is negative 1, and f of 3 is 10. So 3 times negative 1 is negative 3, and 10 minus 10 is 0. So we end up with 0 over 0, and that's a L'Hopital situation. So I'm going to go ahead and cross all that off, and we're going to say, since direct substitution yields 0 over 0 by L'Hopital, the limit as x approaches 3 of our original expression is going to be equal to the limit as x approaches 3 of the derivative. Now, the bottom, we'll do that first. The derivative of f is f prime, and the derivative of 10 is 0, so that just goes away. On the top, the derivative, well, we have a constant multiple here, and constant multiples just stay. But this is going to be a chain rule here. So we do the derivative of the outside times the derivative of the inside. And the 3 goes away because the derivative of 3 is just 0. And then we go ahead and try direct substitution again. So, plugging in 3, I get 3 f prime of g of 3 times g prime of 3 over f prime of 3. Okay. First of all, we'll do g of 3. G of 3, according to our table, is equal to 4. So I'm going to put a 4 in here now. Then we're going to find all 3 of these. All right, f prime of 4 is 3. G prime of 3 is 2. And then finally, f prime of 3 is negative 4. And so I've got 3 times 3 times 2, which is 18 over negative 4, which reduces to negative 9/2. Okay, that's it for that one.